Hello, my dear students. Welcome back to Easy Notes. Today we'll be starting our part B of second chapter, that is different forms of energy. Okay, let's study our different forms of energy. In first part, we have studied about work, power, and energy. But in detail, you have to learn about energy. So we'll be learning here. First thing is mechanical energy. What is mechanical energy? The capacity to do mechanical work is called mechanical energy. What is mechanical work? See here, the energy possessed by a body due to its state of rest or due to its motion. Any energy, if a body is containing due to state of rest or motion, that will be known as its mechanical energy. So mechanical energy is of two types. It is kinetic and potential energy. So the total mechanical energy can be written as kinetic energy plus potential energy. It will be divided into two types: potential energy and kinetic energy. Potential energy will be due to state of rest. Kinetic energy will be due to state of motion. So we'll be learning one by one. So potential energy. What is potential energy? The energy possessed by a body by virtue of its position or configuration. See, if this is a body, I am changing its position from here to here, there will be some potential energy stored in this body. If I am displacing this body or changing the configuration of this body, so there will be some potential energy in this body. Okay, so any changes in a body in the state of rest is known as potential energy. Okay, either it can be changed position or it can be changed configuration. That is nothing but potential energy. It is denoted by the symbol U. Example: what are the examples? A body is placed at a height above the ground, a compressed spring, a bent bow, or a stretched rubber string. Any of these things. Change in configuration or change in position, that will be nothing but the energy stored will be potential energy. Simple. Okay. Now, forms of potential energy. There are two forms of potential energy. Due to two of them, change in position and change in configuration. So, in mechanics, potential energy is mainly of two kinds: gravitational potential energy and elastic potential energy. Gravitational potential energy is due to change in position, and it is due to change in configuration. Okay. Now, note point. It is a simple thing that we have learned before. See, the gravitational potential energy of a body at a height h above the ground is measured by the amount of work done in lifting it up from the ground to height against the force of gravity. So much they have told. In simple terms, I'll say, what is energy? Energy is a form of work. See, to take this body from here to here, how much work I am doing? That is nothing but mgh. Yeah, yes sir, mg into h, because the force acting will be mg and displacement is h. This work will be stored as energy. Simple. The gravitational potential energy of the ground is zero. See, if this is the reference point, here gravitational potential energy will be zero. So from here to here, if I am taking this work done, to take it from here to here is nothing but a potential energy. In simple terms, we can say that work is a form of energy. So the work done for this body to take from here to here is nothing but its potential energy. That is nothing but mgh. We have learned it before in the last previous lecture. Next, kinetic energy. What is kinetic energy? If we talk about kinetic energy, it is the energy possessed by body due to its motion. Due to motion, there is an energy possessed. It is denoted by the symbol K. Example: what are all the examples? Anything which will be moving. Simple. A fast moving stone has the capacity of breaking a window pane on striking it, and thus it has a kinetic energy. Why will it break? Because the body will be having some energy. That's why the stone will be able to break the window. Right? Which energy? That is kinetic energy. Similarly, a car in motion. If the car in motion comes and hit you, you will go and fall there. Which energy was car having? Car was having kinetic energy. Right? Moving hands of a clock. They are also having moving bullet fired from a gun, a rolling ball, or an apple falling from a height h. Anything which is moving has which energy? Kinetic energy. Okay. Forms of kinetic energy. There are of three types: translational kinetic energy, rotational kinetic energy, and vibrational kinetic energy. Translation kinetic energy means if the body is in a translation motion, that is nothing but in a straight line motion. So it will be having translation kinetic energy. If the body is in rotational motion, it will be having rotational kinetic energy. If the body is vibrating at the same place, it will be having vibrational kinetic energy. Simple, three forms. Okay, next expression for kinetic energy. Let us study. So you learn this. Kinetic energy is possible by so and so thing. That's told the same thing. The amount of work which is responsible in moving the body from here to here. So let us understand from here. Okay, come here. There is a body. Okay, which is initially at rest. Now, if I am applying the force F here, what will happen? The body will get displaced from here to here. It will get some acceleration, right? If I'm applying force, there will be some acceleration. The body will move here and get velocity v. Right. So now what is work? Work is nothing but force into displacement, because force and displacement are in the same direction. So work is equal to, what is the force here? Force is nothing but mass into acceleration, m into a. The mass is m, and here if the acceleration is a, if the body is accelerating here with acceleration a, so m into a. What is displacement? We have learned before this formula, v square minus u square is equal to 2a into s. In 9th standard maybe, equations of motion. Yeah. So initial velocity is 0, so this term will be 0. So v square is equal to 2as. So what will be s? S will be equal to v square upon 2a. S will be v square upon 2a. We substitute it here, v square upon 2a. So a will get cancelled. So work done will be equal to mv square by 2. So this work done will be stored as kinetic energy. So kinetic energy will be equal to half mv square. It's the actual formula for kinetic energy. Easy, right? See, kinetic energy possessed by moving body is equal to the amount of work which the moving body can perform before coming to rest, or vice versa, in rest to motion, motion to rest, or rest to motion, anything. Okay, it can be calculated by the amount of work done by the opposing force to stop the body. Okay, done. Next, relationship between kinetic energy and momentum. Momentum you might have learned before. What is momentum? The motion contained in a body. So there are two formulas. Let us consider. We know that kinetic energy is equal to half mv square, and momentum is nothing but m into v. Momentum is m into. So kinetic energy is equal to half mv square. What happens if I multiply by m and divide by m? No problem, right? Because ultimately it will get cancelled. Now, kinetic energy is half m into m square v square by m. I can read it as half mv the whole square divided by m, right? M square v square is nothing but mv the whole square. What is mv? Mv is nothing but p. So therefore I can conclude that kinetic energy is equal to p square by 2m. Kinetic energy will be equal to p square by 2m. This is the relation between kinetic energy and momentum. Okay. So from here, if they ask, kinetic energy is directly proportional to mass when velocity is constant. That is nothing but speed is constant. See, kinetic energy is equal to half mv square. It is directly proportional when v is constant. Okay. And kinetic energy is inversely proportional to m when p is constant. That is, momentum is constant. When momentum is constant, it is inversely proportional. When speed is constant, it is directly proportional. Okay, done. Next, work energy theorem. What does work energy theorem say? It says that the total work done by all the forces is equal to change in kinetic energy. This is the actual work energy theorem. Now we need to prove that. Simple. So let us consider a body of mass m. Body of mass m, which is initially moving its speed u. There is a speed u now. If a force of F is applied to accelerate it, we are applying a force F which is accelerating it with acceleration A to a speed V. So it got displaced and it gained the speed V. Then what happens? Simply we'll calculate it now. What will be the work done here? Work done is force into displacement. So work done will be, what is force? Force is mass into acceleration into displacement. So we'll calculate it here. V square minus u square is equal to 2as. We know this. So from here s will be equal to v square minus u square by 2a. We'll substitute it here. Instead of s, it will be v square minus u square by 2a. So a gets cancelled. So work done will be equal to mv square minus mu square divided by 2. So I can write it as w is equal to mv square by 2 minus mu square by 2. It is nothing but half mv square minus half mu square. What is the formula for kinetic energy? It is half mv square. V is what? Speed. It can be final as well as initial. If it is the final speed, we can say it as final kinetic energy. If it is the initial speed, we can say it as initial kinetic energy. So work done is nothing but change in kinetic energy. So we have proved it. The total work done by all the forces is equal to change in kinetic energy. Easy? Easy. Next. Difference between potential and kinetic energy. So simple. First thing will be their definitions, right? So the energy possessed by a body due to its change in position or change in size or shape. It is nothing but configuration. It is the energy possessed by a body due to its state of motion. It is equal to the work done in bringing a body to its changed state. It is equal to the work done in moving a body before coming to rest. It can change only in the form of kinetic energy. Listen here. Potential energy can be changed only in the form of kinetic energy because potential energy only can gain some speed. But kinetic energy can change into any other form. It can be converted into heat energy, it can be converted into electric energy, chemical energy, light energy, any energy. Okay. It does not depend on the speed of body, but kinetic energy depends on the speed of body. Simple. These are the four different difference of kinetic and potential energy. Done. Next, some questions. How fast should a man weighing 600 Newton? What is the weight of man? Weight, that is nothing but mg. That is how much? 600 Newton. Okay. Run so that his kinetic energy is 750 joule. What is the kinetic energy given? 750 joule. Okay. G they have taken as 10 meter per second square. How fast? That is nothing but we need to calculate V. From here mg, can we calculate mg is equal to 600 Newton, right? Can we calculate m? Yeah, mass we can calculate. So m is equal to 600 divided by g. That is nothing but 600 divided by g is 10. So mass is how much? 60 Newton. What is the mass of body? 60 Newton. So we'll substitute. Kinetic energy is equal to half mv square. So kinetic energy is 750 is equal to half m is how much? 60 into v square. So 2 ones are 2, 2 30s are 60. So 750 divided by this 30 is equal to v square. So 0 gets cancelled. 3 into 25 will be 75. So from here v square is equal to 25. So v will be equal to root of 25. That is 5 meter per second. If a man weighing 600 Newton runs with the speed of 5 meter per second, he'll be gaining the kinetic energy of 750 joule. Is it? Too easy. Next, a block of mass 30 kg is pulled up a slope as shown in the figure in this way with a constant speed by applying a force of 200 Newton. How much force is applying? 200 Newton. Parallel to the slope from initial position A to final position B. Calculate the work done by the force in moving the block from A to B. This we have learned in last class. Work done from moving from here to here. This distance are given 3 meters. So we know the work done. So you have to calculate this. Okay. You have to comment this. Same question we have done in last lecture. The potential energy gained by the block. What will be the potential energy gained by the block? Simple. Potential energy is nothing but mg into h. What is h here? H is the vertical height. Okay. So u is equal to mass is how much? 30. G is 10. Height is 1.5. So 300 into then 3000. 3000 into 1.5 will be 4500. 4500 joule. Is it? Right? 4500. Is it right? Yeah, right. Next question. In a dam, water falls at a rate of 1000 kg per second. That is nothing but dm by dt. That is nothing but 1000 kg per second. Mass per unit time is how much? 1000 kg per second. From a height of 100 meter. Height they have given 100 meter. First up question. Calculate the initial potential energy of the water falling per second. Initial potential energy. Potential energy is mg into h. Falling per second. Initial potential energy per second. Time is how much? Time they have given per second means 1 second. Okay. So I have to calculate this. Tt will get cancelled. Sorry. We won't cancel. It will become same. M is how much? See, m by t. M by t is how much? 1000. Directly we can write per second. They have given per second. Simple. In 1 second itself they are asking. Into G is 9.8 they have given here. So we'll take 9.8 into H is how much? 100. So 9.8 into 100 will be 980. 980 into 1000 will be 9,80,000 joule. Okay. This is the initial potential energy per second. Next, assuming that is 60% of the energy of the falling water is converted to electrical energy. So what they are saying, electrical energy is nothing but 60% of potential energy. Okay. Calculate the power generated. Okay, power due to which electrical energy. Okay. Let's see. First we'll calculate electrical energy. What will be electrical energy? That is 60%. That is nothing but 60 upon 100 into initial potential energy. That was 9,80,000. So 1, 2, 1, 2 zeros will be cancelled. So electrical energy will be equal to 60 into 9800. So 98 into 6. Calculate it. 6 8s are how much? 6 8 are 48. 6 9s are 54. It will be 588,000 joule. This is the energy. So can we calculate power? What is power? Power is nothing but electrical energy per unit time. So that is 588,000 divided by time is 1 second. Per second they have told, right? So time will be 1 second. So it will be remaining same. 588,000 watt. So this is the power generated in that what? Due to that water in the turbine maybe. Okay. Done. Next question. A bullet of mass 5 gram travels with a speed of 500 meter per second. Mass is how much? 5 gram. That is nothing but 5 by 1000 kg, because always we need to write in terms of SI unit. The speed of 500 meter per second. 500 meter per second. Okay. If it penetrates a fixed target which offers a constant resistive force of 1000 Newton. Resistive force means negative direction. Opposite resistive force is 1000 Newton to the motion of the bullet. Okay. Find the initial kinetic energy of the bullet. Initial kinetic energy and also the distance through which the bullet has penetrated before coming to rest. That is nothing but displacement. Simple. So first we'll find initial kinetic energy. Kinetic energy initial, that is half mu square. This is u, right? See, this is u. Why I'll say? Because it is traveling with a speed of 500 meters per second. If it penetrates, the resistive force will be acting, and it is coming to rest finally. So initially it was having some speed. Due to resistive force, it stopped here. Okay, so this is initial speed. So kinetic energy initial will be equal to half. Mass is how much? 500 by 5 by 100, right? 5 by 1000 into u is how much? 500 meter per second. That is nothing but 500 into 500 square, right? So 1, 2 and 3 zeros. 1, 2 and 3 zeros will get cancelled. So kinetic energy initial will be 5 5s are 25. 25 into 5 will be 125. So 1250 divided by 2. 1250 divided by 2. How much it will be? It will become 2 6 are 12. 2 2s are 4. 2 5s are 10. 625 joule. This is the kinetic energy. Next, they are asking the distance before coming to rest. Simple. We know that work done is nothing but kinetic energy final minus kinetic energy initial from work energy theorem. What is work done? Resistive force into displacement. That we need to find out displacement. Final kinetic energy will be 0 because it is coming to rest. Because final speed is 0, final kinetic energy will also be 0. Minus, we'll write 0 minus initial kinetic energy is half mu square. But we know initial kinetic energy, so we'll write it as initial kinetic energy. We have just calculated. So resistive force is how much? Minus 1000 into S is equal to 0 minus means it will become minus itself. Minus 625 joule, I think. Yeah, it is 625 joule. So S will be equal to minus and minus gets cancelled. It will be 625 divided by 1000. So S is equal to 0.625 meter. So by after traveling 0.625 meter, the body or the bullet will come to rest. The bullet of mass 5 gram will come to rest. Okay. Next, Richa weighing 40 kgf. Weight they have given. How much? Weight is 40 kgf. That is nothing but 400 Newton. 40 into g. 40 into g. The value of g I have taken here as 10 meter per second. I have given also 10 meter per second. So here mass will be how much? 40 kg. Simple. Mass will be 40 kg. In simple terms, 1 kgf is equal to g Newton we have studied. So by removing g, that will become mass. Okay. Leaves a point P. Point P. Okay. Rest on her skateboard and reaches point Q from the ground with velocity of 10 meter per second. Okay. She'll reach here by point Q by 10 meter per second with speed of 10. Calculate the kinetic energy of Richa at point Q. Let us calculate one by one. Kinetic energy at Q. That is half m velocity at Q square. So kinetic energy at Q will be half. What is m? Mass is 40 kg into velocity at Q is 10. 10 square will be 100. So 2 ones are 2, 2 20s are 40. So kinetic energy at Q will be 20 into 100 will be 2000 joule. This is the kinetic energy at point Q. Okay, done. Next, what they are asking? The vertical height of point P above the ground. Vertical height, this vertical height they are asking. So we will calculate that vertical height. How can we calculate? From here to here, see, if Richa was h height above, she was having potential energy, which got converted into kinetic energy, right? So how much potential energy she was having, the same energy got converted into kinetic energy at Q. Potential energy at P will be equal to kinetic energy at Q. So what was potential energy at P? Mg into h. Kinetic energy at Q we have got 2000. So M mass is 40, G is 10 into H is equal to 2000. So H is equal to 2000 divided by 40 into 10 will be 400. So 0, 0, 0, 0 gets cancelled. 4 5s are 20. Height will be equal to how much? 5 meter. Height is how much? 5 meter. Easy. The point P was above how much? 5 meter above from the surface. Next thing they are asking is the kinetic energy of Richa at point R. At point R we need the kinetic energy. While moving from Q to R, she loses 500 joule of energy against friction. Let's see. We need kinetic energy at R. We know that work done is equal to kinetic energy final minus kinetic energy initial. So work done is force into displacement. Okay, force into displacement will do work. Right? Okay. Now what is force? Force is mg. Force is what? mg. Displacement is h. Simple. Okay. What is kinetic energy final? Kinetic energy at R minus kinetic energy initial will be kinetic energy at Q. Right? Okay. So what is mgh? See, kinetic energy at R will be, we also have to subtract what here? We also have to subtract this. At last we'll have to subtract this 500 joule as well, because from coming from Q to R it has lost 500 joule of energy. So we'll subtract later. Okay. What is M? Mass was 40 into 10 into height was how much? 5. Okay. Just a minute. From here to here, right? Work done. What will see here? Height is 3 meter here, not 5 meter. I'm taking it 5 meter here. Height is how much? 3 meter from there to there. And we'll be taking this as negative y negative, because it is going from down to up. Mg will be acting downwards, h will be upwards. So opposite direction cos 180 will be minus 1. Now kinetic energy of R minus kinetic energy of Q was 2000. So we solve this. 4th is at 12. So it will become minus 1200 is equal to kinetic energy of R minus 2000. So if this 2000 comes here, kinetic energy of R is equal to 2000 minus 1200, right? This will be positive. We also have to subtract what? Lastly we'll subtract, right? Kinetic energy of at R will be equal to, it will become 800 joule minus what we have to do? We have to remove this energy, minus 500 joule. So therefore actual kinetic energy at R will be 300 joule. This was the kinetic energy at R, but due to heat some energy, extra energy was lost. That's why we are subtracting that energy. So actual energy will be 300 joule. I hope you have understand this. Next, two bodies A and B have the same kinetic energy. Kinetic energy of A is equal to kinetic energy of B. Okay. Compare their velocities. If the mass of A is 4 times mass of B, there is nothing but mass of A is nothing 4 times mass of B. We'll solve. Formula is half MA VA square is equal to half MB VB square. So half and half gets cancelled. For MA, what we can write? We can write 4 MB into VA square into MB VB square. MB also gets cancelled. So 4 VA square is equal to VB square. So VA square upon VB square is equal to, this will be 1 by 4. This 4 comes here. From here, VA upon VB is equal to root of 1 by 4. Right? The square goes here. It will be 1:2. Therefore, I can write as VA is equal to 2 times of, if this 2 comes here, it will be VB is equal to 2 times of VA. VB is equal to 2 times of VA. Just we need to compare the velocities. Next, if the kinetic energy of a moving body is 40 joule, kinetic energy how much they have given? 40 joule. Then what will be its kinetic energy when its velocity is doubled? Okay, let us consider V1 is V. So what will be V2? V2 is 2V. So kinetic energy 1 is 40. So what will be kinetic energy 2? They are asking. So kinetic energy is 1 is nothing but half mv square. So we'll solve kinetic energy 2. Kinetic energy 2 is half m. Mass is same, v2 square. Okay. So kinetic energy 2 is equal to half m. V2 is 2v the whole square. So we can write it as half m 4v square, because 2v square is 2v the whole square will be 4v square. So kinetic energy 2 can be written as 4 into half mv square. Now what is half mv square? It is kinetic energy 1. So kinetic energy 2 is equal to 4 into kinetic energy 1. So 4 into 40. It is nothing but 160 joule. Kinetic energy 2 is how much? 160 joule. Easy, right? Next question. Differentiate between watt and water. I'll just say, you can remember that. What is watt? Watt is nothing but when 1 watt of when the energy is done, if the power is generated 1 watt in 1 hour. Hey, just a minute. What is watt and watt-hour? I thought watt-hour and kilowatt-hour. See, what is watt? What is the difference we need, right? What is the unit of power and watt-hour is the unit of energy, right? What is said to be 1 watt when 1 joule of work is done in 1 second. Watt-hour, 1 watt-hour is nothing but it is a commercial unit. It is used when the energy is spent to deliver 1 watt of power in 1 hour. So those are the two differences, you can write it down. Next, a machine raises a load of 100 Newton. Force is how much? 100 Newton. Sorry, 1000 Newton. Through a height of 10 meter. 10 meter in 10 seconds. Calculate the energy spent by the machine. We need to calculate energy first. Power at which machine works, we need to calculate power. Horsepower and kilowatt are the units of which physical quantity? How are they related? I'll say it is of which physical quantity means it is the units of power. How are they related? 1 horsepower is equal to 746 watt. Next, if the power of motor is 50 kilowatt, at what speed it can raise a load of 20,000 Newton? This is for second. We need to calculate energy and power. Energy is nothing but a form of work, that is nothing but force into displacement h. You can find energy from here. Then power will be equal to energy by time. You must comment it down. Solve by yourself. Force into height, then energy by time. Next, lastly, what is asking? Power they have given and force they have given. Power is how much? 50 kilowatt. That is nothing but 50,000 watt. And force they have given 20,000 watt. 20,000 Newton. So what will be speed? So P is equal to Fv. So V will be equal to P by F. Just substitute it and solve it. Both you have to answer. This you have to answer by second sub question. Question number 8, second sub question. First, energy and power. Okay, energy is so and so and power is so and so. Then question number 8, fourth one, and velocity is so and so. Let's move for the next question. Okay. The mass of the block P is 5 kg. Okay, is to be moved along the inclined plane AC of length 8 meter. Okay, done, which makes an angle of 30 degree with the horizontal. A force of 15 Newton is applied on the block to move it through the inclined plane, as shown in the diagram. Same question we have done. Let's see what they are asking. What is the work done by the force? This you need to solve. Because work done, 3 times I have asked. You need to solve. Work done is nothing but force into displacement. 50 into 8. 5 8s are 40, right? So 4000 joule. It will become 4000 joule. Simple. I have only solved. 5 are 40. 400 joule. 15 to 8, right? 400. Next, find the gain in potential energy of the block P if it is directly lifted to C from the ground. So we need to find this distance h. So we'll find h. Sine 30 degree is equal to h by 8. So half is equal to h by 8. 2 ones are 2 fours are 8. H is equal to 4 meter. So potential energy is nothing but mg into h. So mass is how much? 5 kg. G is 10 they have given. Let's take it as 10. They have not given anything. Into h is 4. 5 4s are 20. 20 into 10 is 200 joule. This is the gain in potential energy, extra potential energy. Okay. We know that the potential energy is gained due to the work done on the body against gravity. Then in this case, why is the work done on the block and the increase in potential energy of the block different? Why are these two different? This is 400, this is 200. Why? Because some energy is lost due to friction. We need to write the answer what? Some energy is lost due to friction. How much energy? 400 minus 200. 200 joule of energy is lost due to friction. Let's move. A car of mass 120 kg is moving at a speed of 18 km per hour. How much? 18 km per hour. So mass they have given 120 kg, moving at speed of 18 km per hour. Initial speed is 18 km per hour. And it accelerates to attain a speed of 54 km per hour. Final speed will be 54 km per hour. Okay. In 5 seconds, time they have given how much? 5 seconds. Calculate the work done by the engine and power of the engine. So we'll solve this array. What is this happening? Let's see. So first what we need to calculate? First we need to change these two in terms of meter per second. Remember here, to convert kilometer per hour to meter per second, multiply it by 5 by 18. Remember this. This is the easiest way to convert from kilometer per hour to meter per second. So let us convert. So U is equal to 18 into 5 by 18. So 18 gets cancelled. It is 5 meter per second. Final loss is 54 into 5 by 18. So 18 3s are 54, 5 3s are 15 meter per second. So we got both the speeds. We need to calculate the work done. Simple. What is work? Work is change in kinetic energy. Kinetic energy final minus kinetic energy initial. So that is half m v square minus half m u square. So work is nothing but half m is constant. It will become v square minus u square. So work is equal to half. What is m? Mass they have given 120. 120 into v square is 15 square minus 5 square. Right? So W is equal to, it will become 60 into 15 square is 225, 5 square is 25. So W is equal to 60 into 225 minus 25 will be 200. 6 2s are 12. So it will become 12,000 joule. This much of work is done by the engine. Okay. Now, next, what is the power? Power is nothing but work done by time. So work done is 12,000. How much is time? Time is 5 seconds. Divided by 5. So 5 2s are 10. So 5 4s are 20. It was 0. 2,400 watt. 2,400 watt. Okay. Next. different forms of energy. What are the different forms of energy we'll study? First is solar energy. The energy obtained by the sun in the form of heat and light is called solar energy. It is used through devices like solar panels and solar cells. Next is heat energy. It is the energy released on the burning fuels like coal, oil, wood. It's called heat energy in the form of heat. It has the capacity to do work such as producing steam. Okay. Next is light energy. It is a form of energy that enables us to see objects. The sun is main natural source of light energy. Due to sun, we can see the objects around us. Chemical energy. The energy stored in the fuels, food, batteries, etc. Wherever the chemicals are used, the energy produced will be nothing but chemical energy. Next, hydro energy, the energy possessed by fast moving or stored water. Fast moving water or stored water. Energy due to water is nothing but hydro energy. It is used to generate electricity in hydroelectric power stations. From water we can generate energy. Electrical energy, due to the movements of electrical charges. If the charges move from here to here, there will be some energy generated. That is nothing but electrical energy. Nuclear energy, it is due to nuclear fission or nuclear fusion. In the nucleus of an atom, there is a nucleus of an atom, there will be protons and neutrons, there will be some fission and fusion going on. We will study in the last chapter of this class, that is radioactivity. Okay, just remember here, it is due to nuclear fission or fusion. Next, geothermal energy, it is due to the deep inside, due to earth, nuclear disintegration inside the earth, geothermal. Okay. Next, wind energy, it is due to fast moving air, wind. Due to wind, there will be some energy produced. These are the different types of energies. Okay, some more. Sound energy, the energy produced by vibrating objects. See, vibrating objects, there will be some energy produced due to vibrating objects. That is nothing but sound energy. Through that we can hear, and it is sensed by our ears. Magnetic energy, it is energy produced by magnet, due to which it attracts magnetic materials. Right? If there is some energy in the magnet, it will attract magnetic material. If there is no energy left, it can't attract the magnetic material. Mechanical energy, this you have learned before. The energy possessed by a body due to its motion or position is called mechanical energy. Then these are the different types of energy. Now we can study the conversion of energy from one form to another. Just remember these many, because they have given in the textbook. See, dynamo is nothing but producing mechanical energy. It gets converted into electrical energy. Or motor, electrical energy into mechanical energy. Right? Mechanical to electrical means due to this working, there will be some electricity generated. Due to this electricity, there will be motors will be what? Motors will be used and generators will be used, like that. Electrical energy to heat energy, that is nothing but iron to any heat energy. You have to give heat to any object, we can use iron. Next, electrical energy to sound energy, right? Loudspeaker energy, microphone and all will connect and will speak in the mic. Next, electrical energy to chemical energy, the cells or the batteries. Chemical energy into light energy, right? The chemicals in the candle were being produced. What will they'll produce? They will produce what? Combustion will be happening there. So that's why there will be a light produced there. And light energy due to sun as well. The sun falls on the what? On the tree or on any leafy part, there will be a photosynthesis occurred there. Next, electrical energy to light energy. Okay. Next, questions. Which among the following is a vector quantity? Work scalar, power scalar, energy scalar. Moment of couple. Last chapter we have studied in force. Moment of couple is a vector quantity. What is the correct energy transformation during burning of candle? Burning of candle is from chemical to heat, right? So heat to chemical, no, chemical to heat, right? Chemical to heat plus light. Next, in a burning of coal in a thermoelectric station, the energy conversion takes place. Conversion. Burning of coal. Coal was initially chemical. So chemical. So this one will be there. Chemical to it becomes heat energy, right? Burning of coal. So chemical to heat. Oh, all the three. Next, in thermoelectric station, so thermoelectric station means there will be some mechanical work. So there will be some mechanical work. So this is also gone. Directly light. No light there. Next, thermoelectric station. So it will produce some electricity as well. So to electrical. So chemical to heat to mechanical to electrical. All these processes will be going on in burning of coal in a thermoelectric station. Next, the energy conversion in washing machine. Washing machine, what do we do? What do we do? Electrical energy, as soon as we connect, it will be washing that. That is nothing but mechanical. So electrical to mechanical. Done. This is the energy. This is the part 2 of different forms of energy we have studied here. Potential energy, kinetic energy, solar energy, this energy, that energy, conversion of energy. In the next part, part C, we'll be studying about conservation of energy. Okay. So from one part to different part, from here to here, the energy will always be conserved. This, that, and all we'll be studying in the last part of this chapter. So till then, download the Ezee Notes app, and till then, keep studying and keep achieving your goals. Bye bye.